Welcome to Algo Guru, and on this video we are going to take a shot at some more of arrays related problems. So let's jump into it. Alright, the first problem that I want to take a look at is this one. This is related to multiplying two integers which are given in the form of two arrays. So I have two arrays over here. The array 1 contains three elements 1, 2 and 3. So that forms the integer 123. And array 2 has again three elements 3, 2, 1, and that forms the integer 321. And when 123 is multiplied with 321, you get 39483, and this is also returned in the form of an array. If you're wondering like why would such a thing is needed, and you can even in terms of thinking like, okay, it could be simple, like you just like take each element and make an integer or long or something like that and then multiply it, you can get it. But what if the array contains like 100 elements? There is no built-in data type which can hold 50 or 100 digits in it. That's going to blow up any built-in types. So in those cases, something like this is going to come in very handy, because you can have arrays of size anything, especially if you are using like a vector. You can have that super big, and that's definitely going to help with this kind of multiplication. So where do we start with this thing? The first step, I have this function prototype which is going to return a vector of integers, and it's going to take two vectors, vector A and vector B. And the first step is actually getting the sign. What is this? What, for example, if this was minus 3? So that means the number here is minus 321. What if this is also minus? Then this number is minus 123. Now if we multiply a negative number with another negative number, the answer is always a positive number. But what if just one is negative? Then this will obviously become a negative number, right? So we have to take care of that particular condition, and that's what I'm going to do actually in the first step. Alright, so basically what I have to do is that I have to look at the first element and see whether this is less than 0. Okay, and then I also have to check whether b dot friend. Okay, so before I do that, I have to make sure that I'm doing something like this, and this is like an XOR operator. Why I'm using the XOR operator? Because this is going to make sure that it is going to do an XOR of these two numbers. And the friend is basically the call to the very first element that is going to be at index 0. So it is going to take the first element and see whether it is less than 0. If it is less than 0, so that means that it's a negative element. And then going forward, we will also want to make sure that we want to eliminate that negative number, because you don't want that negative number to be there when you do all your calculations, because that's going to make it a mess. So what are we going to do for that? We just have to do something like this, right? So we are going to take an absolute value for the calculations, because we already have taken care of getting the sign. So now we can just remove that negative value, if that negative sign, if at all it is there. Alright, and the next step is actually create another vector which will be the result. And at this point we know that the size, it is going to be something of a size of A plus size of B. That's what will be the size that we are going to allocate. And now we have to start from, because there are two arrays, so you have to take one array and then you are going to go through the other array, something like a nested for loop, which will take a time complexity of n square. So let me write this. So this is going to be the first array, and then I'm going to reduce I until I becomes 0. So inside that I will have another array which will be for the second array, uh, another for loop for the second array, and again it start at the last index, and then it will be going until it becomes 0. So now let's get the whatever is the product of the two numbers. So what is this like? So okay, so we are going to take like something like this. For example, the first time the loop goes is going to be 3 multiplied by 1. That's it. It's as simple as that. And once you get that, you want that to be added to this index, which in this case, like for in this example, it will be like I will be 2, j will be 2, plus 1, 5. So in this particular case, we have created an resultant array of size 6. So the last index, that's where you will start. So something like this here. You are going to add 3. 3 multiplied by 1, which will be 3. So you want to add that over here. So it's just a little bit tricky, because you basically, what you are going to do is that you only want to like add the lower limit. Okay, so what if it is like 12, like if it was 3 multiplied by 4, 12. At the last index you only want 12, 2, and the index before that you wanted to add 1. So that's what we are doing over here. So this is the index right before that, and what are you going to have over there? So it will be like sum multiplied by 10. In this case it will be like this 0, but in general, if it was a value like 12, then 2 will come at the last index and 1 will come the index before the last. That's what this code is going to do. And once we are done with that, we basically go through the loop and do pretty much everything that needs to be done. And now there is a trick over here. Like you can see, we created a resultant array of size 6, but we are not using all of that, right? We are only using like 5. So the last index is going to be 0. Do we need that to be 0? No, we don't want that to be 0. So what are we going to do? So there is a very simple technique that we can do in C++, by which we can actually remove the any leading zeros can be removed. Let's take a shot at that. Return a is equal to 0, and then we will come out of this, and then we will do like another result. That's pretty much it. Alright, so this will actually take like all the leading zeros out. And now we are not going to look at a lot of edge cases in this particular problem. So I'm just going to do something like this. So there is a result dot front. So what that line is going to do is that this is going to add the sign. So if it was a negative 1 which was set over here, then it will just make like this 3 to be like -3 and then just return the result. That's pretty much it. So let's run a program over here. Okay, multiply, and then we will just copy paste this just for a quick purpose. We'll just like copy paste these two things. That's it. And then we will come here and print I. That's going to take care of that. Alright, I had to make a small change over here to like make the sum plus equal to. So after taking the sum, I also need to add whatever was there on that last index. So, and after that it is pretty much the same code. So let me run this, and alright, this is what we get, like 39483, and that is the expected answer for this one. There are going to be like some edge cases. We can look into that too. Like for example, like what if I put like a minus over here? Let's see whether this is going to bring us like the negative 3943. Yes, look at this. It brought like in the negative 39483. We can also try like something like 23, and then you know so this will be 230. Let's see whether it brings 230, and there you go, it brings 230. So that was an easy test. Okay, so that's pretty much it. So I didn't like take care of some of the edge cases, like what if either A or B is empty, and those kind of conditions you will definitely have to take care of the very first line. Alright, next is basically like a form of jump game. Jump game, if you're familiar or with some of these coding problems, and if you have tried some out which are there in the online web, you may have already came across like jump game. So this is like one another form of jump game, and where you are given an array and you have to start at the first index, index 0, and you have to get into the last index. In this particular case, the last index is 6, and the value at each index tells how far you can jump. So at index 0 it is 3, so you can jump to 3, 1 or 0. And at index 1 the value is 3, so you can jump to 1, 0 or 2. So is it possible for you to start at first index 0 and to get into the last index, which is index 6? And in this example you can actually do that. And how you can do it? You can jump from 3, which is at index 0, to index 1, and from index 1 you can jump all the way to index 4, and at index 4 the value is 2, so from 4 plus 2 you can jump to the last one. And let's look at the second test case. You start at index 3 and you can jump up to 0, which is at index 3. That's the furthest that you can go, and the value is 0, so that's a dead end. You cannot go anywhere. But you can also go to index 1, which has a value 2, and so you can go from 1 plus 2, that is 3. Again, that is 3. That is 0, and that's a dead end. So basically you are just ending right here. These are the only 3 places that you can go. You cannot go any further. So that basically ends pretty much that. So how can we do that? So the first step is like we will create a curve which will be called as 0, and this function is going to return a boolean which will tell either if it's possible, then it will say true, or else it will be false. And then we will calculate the last index, which will be like nums of size minus 1, and then we will start I, and we will start I at 0, and then we will keep going until I less than cur, and also like cur less than last. So this is how you are going to go, and at every given point of time you will find the max value, something like this. Then you will have to look at okay, current greater than, that's pretty much it. So at each index you are going to find the max of cur, comma I plus nums of I, which is going to be like, you will calculate at this point, you will calculate what's the index is 1 and the value is 3, so that is like 4. So like that you will like find the max at each different points, and then you will like just keep going further and further. So let's try and see. Let's just run this and see a couple of test cases over here. Alright, so let me just copy paste this one, and I will also have one more over here, JumpGame 2. So this should be ideally returning us false. So let's run it, and here we get JumpGame 1 returns true, and the JumpGame 2 returns 0, which corresponds to false. So that's pretty much it for the JumpGame. Very simple, and an extension of this is basically like how many minimum steps you can take in order to get from the index 0 to the last index, which will be like another level up. Alright, the next one is removing duplicates. This is not exactly about removing duplicates. This is like finding how many unique elements are there. In this particular case, in the first example, you have 8 unique elements, and in the second one you have like 7. So I will rename this to be like unique elements, find, like it should be something like find unique elements. So that's how it is going to be. This question can be also asked in like different variants, like actually like given an array, return an array which will just have unique elements. So you will have to remove like one of these 5, 2 of these 7s, one of these 9, one of 11, and something like that. And an easy way of doing that is using a set in C++ or a hash table when you talk generally in terms of software, which will only contain like unique elements in it or unique keys. So that is one way of doing it. But here we are not going to go anything complex because we don't want to use like any extra space or anything like that. So we will have like a very easy way of doing it, and that's going to be something like this. Plus plus I, and then what we are going to do is that we are going to check whether index, which we are going to set it like -1 is equal to index of I. Then what will we do? Like when we will get like index of x is equal to nums of I, and that's pretty much it. Like whenever there is a difference, so you are initially defining a variable called index to be 1, and the first time you check at nums of 0, nums of 1, and then we will check with nums of 0. If they are different, then you are just basically like uh, incrementing this particular integer, this index, whenever you see like unique elements. That's what you are doing. It's a very simple thing, very efficient, memory efficient. It's done in a time complexity of big of n, and the space complexity is also pretty much the same. It doesn't take any extra space, nothing like that. It's very straightforward implementation, and that's what we want. Actually, we don't want it to be like too complicated, like you use something like a set or something, then it's going to add like all these extra space complexity, which a lot of people doesn't want. Actually, a lot of companies in fact doesn't want that. So when I run these two test cases, I get like the first one returns 8 and the second one returns 7, and that's exactly what the result that we were expecting right over here for these two test cases. Let's jump to a classic problem, buy and sell stock once, and I have also an example over here. And for this array of stock values, the answer is 30. That is the max value. And the problem definition is simple. You have given a bunch of stock values in the order of starting from day 1 to some ending day, and find a way by which you can buy a stock on one day and sell it on another day, and the profit should be the maximum. This is a classic problem. It is there pretty much everywhere. People talk about dynamic programming and stuff like that. Yes, it uses a format, some sort of a format of a dynamic programming, but it is very simple. So how are we going to do this? So let's start by defining a minimum value. So at every point of time, as we traverse through this array, we will keep a minimum element. And we will use that minimum element, like for example, at index 0, the minimum element is 110. And then once we go into index 1, all I have to do is that subtract this 1115 with the last found minimum element, which is 110, and we are going to get the max profit at that point as 5. So again, I am not going to do any what I call like any housekeeping things, because what if this nums is 0? And we could also make this like a constant, you know, like those kind of things, in order to make that, oh, you are not changing. If you can make it like a reference, so that you are not using any stack memory, you're just passing a reference, those kind of things, and then checking whether nums is an empty array or those kind of things, which I'm not going into those details. So please make sure that you are covering those things when you are actually doing this code in a real interview setting. All right, so now I have two variables, min and max. Min is set to be the value at index, whatever is the value at index 0. And then I'm going to start, so I will just eliminate index 0, because the max profit at index 0 is basically 0. There is nothing before that. And then I less than nums dot size, we know that, and then we will keep incrementing this. All right, so at every given point of time you want to find the min. So what will be the min? We will use the platform or the library function min with what is there at that point, whichever is the minimum we have to take, right? And what is going to be the max? Again, we use the library max library function, and then we will take what we got so far. So the first iteration or the first loop, it is going to be 0, and then we got to do this, right? Wherever we are, minus min. So that's going to be the max. Then at the last point, we are just going to return this. So for this given example, it should actually return like 30. Let's see whether it will do it. Best stock value. Alright, the best stock value, we are going to do something like this. Alright, and in order to have like a second test case, we can, why not we use this one which we used earlier for that find unique elements thing. So this should return 30, we know, because where are we getting 30? We are buying at 60 and selling at 90. Here how it should be, like the biggest difference, because this is already a sorted array, so it's not like much of a geek thing. We already know like we have to buy at 2 and sell at 12 with a maximum profit of 10. Let's see whether we get those answers. There you go. For the first test case, we are getting a value of 30, and the second one, we are getting a value of 10. So that's pretty much it. So that's a very simple problem. There are a lot of different variants of this, like there is another variant where you have to buy and sell twice, thrice, and all that kind of things are there. It will get like a little bit tricky, but the starters is basically this problem. And if you look at the real meat, it is just done in 2 lines of code. That's it. That's all that it takes. So that's pretty much for this video, and we will come back and look at more array problems later. Thank you. Take care.